That could be fine. Yeah, we have completed last class what is etching related things. We have completed it, the etching things. We have ended the etching topic over the wet etching and dry etching advantages. So etching should be clear to you guys. So I will be sharing the PPT later up till I think till here I think up till maximum I think I have shared the PPT. So roughly I think this part I have shared the PPT related to from the etching. I think it is not shared. I will share it with you. So today we will be starting ion implantation, which is called ion beam lithography also. Okay, in chip fabrication we works in the ion beam lithography, which is actually related to, which is a very essential and crucial step of the lithography word we used to hear. So we will be starting with the ion beam lithography, which is the fabrication's one major step. Coming to the chip fabrication process, here we will see silicon wafer first manufacturing. Already I discussed the silicon wafer manufacture earlier, which is the called ingot as well, which is the ingot as well, works with the ingot thing, and it works here also. The silicon wafer manufacturer first ingots will be like, let me draw again. Ingot will be available. It looks some kind of this. It looks some kind of this. It will be then cut down, and this kind of wafer shaped will structure will come out, which is then planarized and polished to make the surfaces and then it goes for the fabrication. The first in the step of the fabrication, it is doped with the dopant material. If it is plus doping, then it's a highly dopant. It's a negative doping, then it's a less dopant. If it is a no nothing, then no doping is there. Okay, no plus minus, no doping. So after this structure, it is going for the next step, which is for the end well fabrication, everything. So this is the step where we will be working. One sec. Okay. So this is the step you have all seen. This is the, suppose this is the substrate here. This is P sub. Here the SiO2 is there. Here the mask suppose is given. Suppose here a mask is given, and the light falling from the top is actually this, what actually called the ion beam. This is the ion beam actually falling from the top. It will hit these parts and it will excuse me, and it will hit these areas, and this area is blocked actually. This is a part of the envelope. It will be blocked. Here the light will not fall, only this area the light will fall and will get soft. Then etching process will take care and remove all the part where the light has fall. It has become softened. The light where didn't fall, the mask area, it didn't got soft. It is hard now. So soft material get washed out with the etching process. Okay, this light thing we will be studying. This is the ion beam. For silicon wafer manufacture is there, epitaxial growth. Okay, in this one then photolithography will come across, and then if the photolithography is done, then on that one the diffusion, and which is called the ion implantation process, also takes care in this photolithography process step only. I will be coming to that diffusion thing later. So this photolithography takes care. In this one the oxidation part is there, and one a metallization part is also there, but metallization part generally comes at the last stage. Here the oxidation part is done, then etching, then after at last the same process is repeated again with the metallization process. And metallization is done, then it goes for the packaging. This is a roughly a flow chart of the fabrication step, which we have studied from last couple of days. Just to make sure that you get refreshment, that this chart has been implemented. Okay, it's a flow chart. Now comes to the actual ion beam lithography. What is ion beam lithography? Ion beam lithography is the practice of scanning the focused beam of light. One second. What is this? One second. Okay. So ion beam lithography is the practice of scanning a focused beam of ion. a patterned fashion across a surface in order to create a very small structure, such as integrated circuits or other nanostructure. So it already simplify the statement. Ion beam lithography is a practice of scanning a focused beam of ions in a patterned fashion. Like that patterned fashion means this is suppose the mask, and the actual structure, if I tell you very frankly, wait, let me tell you, the machine inside the latest machine, which is the ASML. Okay, ASML actually the EUV for 2 nanometer, this lithography machine actually work. The light is actually focused at this level. Will be there in 45-degree angle, mirror is there, so the light falls at this level. Okay, the light falls at this level, then this light is fall again at this level, again 145-degree angle mirror will be there. There it will fall once again like this. Again one mirror will be there. So it actually, this light actually has very very high strength. If that is not required, then it's reflected and polarized here, and then this is taken care, and here these things will be there. Either this will be inverted set, or this the wafer will be at this level. Okay, and then one mirror, and it will strike this mirror directly to this part, and this is the wafer actually. This is the wafer. The structure of the new ASML EUV200. One other structure will be there, is like a 90-degree angle will be there here. Okay, a 90-degree angle will be there at this level. Okay, then it will be focusing, and the wafer will be directly here. Directly, wafer will be rotating at this level, and the light will directly come, and it will be falling from a pointed shaped nozzle. If it's not a, it's actually making the light thinner. Okay, if you see the light in a reflector where it is given in a car or a truck, the light expands, that the what the range of the lights falls on a in a multiple direction, so that we get huge number of light in the front of our car. But if we don't put reflector there, then what will happen? A straight beam of light will go. That will not be essential to drive in the night. That's the reason here it is opposite. It is actually pointing it down. It's making narrow. It's not widening it actually. Then it is falling over this wafer to make it patterned. Okay. Excuse me. Via this mask. From this mask, it is actually pointing the light, and wherever it is actually facing this obstruction, it will not pass. Wherever it is not facing obstruction, it will pass the light, and it will make it the wafer etches. Okay, okay. So if you go and see the ASML, let me show you how a lithography machine looks like. Let me write here ASML. Okay, ASML EUV lithography system. Let me show you how it looks actually. Okay, let me show you. The ASML is the bigger manufacturer of this lithography machines. If you see this image, you will get to know how the beam of light is actually coming from that area. Okay, so wafer is actually at this below level. Okay, and the light actually comes from originated source, and it is reflected via multiple mirrors at a different angle, and it is falling on this particular source, this wafer. This is how a internal structure of the lithography machine actually looks like. Okay, there are multiple companies apart from the designing companies like Intel or Texas Instrument, NXP. See, the highlight of the companies are, first, the service based company comes, which are responsible for designing the chips from the product companies. They take the projects from the product company, they design and send to the the service based companies are HCL Technologies, Tech Mahindra, Sirium Systems, Capgemini.
Hello, sir, we can't hear you, sir.
Hello, can you hear me?
Yes, sir, we can hear.
Till what time you are able to hear me?
Your voice is breaking, sir.
Now also?
No, it is fine.
No, till what time you have able to hear me?
Just
Last.
like Intel, you're saying about the companies that are going
Okay.
to manufacture.
Then fine. Then fine. So Intel, AMD, NXP Semiconductor, Texas Instrument, these are Samsung. These are the major product-based companies. Some of them have a fabrication plant. Intel, Samsung, they have own fabrication plant also. Okay, but these are considered as a product-based company. Apart from there are multiple big service-based company like HCL Technologies, Tech Mahindra, Serium System, Capgemini, Ultron Engineering, and Moschip. These are the majority big companies which Tata also, Tata Alexis or TCS also. They actually controls the service-based market across the world. They are very big actually. HCL itself is a very huge company. They deals with they have tons of project. If you are getting inside HCL Technologies, like frankly, if I say salary point of view, don't ask. It will bit less from that company, but the project is enormous. They have salary will bit less compared to product. Of course, it will be less, but they have enormous project. HCL Technologies. Other companies, if you come to product companies, they will give like Intel and other companies are there. Apart from these are the designing part. Apart from there is a set of company which is called TSMC, Intel Fab, which is called IF, Samsung Fabrication. These are fabrication plant. They require some machineries and a raw material also. Okay. Apart from this, there are three companies. There are Cadence, Synopsys, and Mentor Graphic. These are EDA companies. They provide tools for designing what we are using: Cadence, Mentor Graphics, Caliber, or uh, Synopsys tools also we use. Okay, so these are EDA tool. Apart from that one, in the fabrication plant they require machineries to build this kind of chips complicated. That company is the ASML is one of the biggest company to provide this kind of machinery. ASML is there, Lam Research is there, Teradyne is there, Daifuku is there, Oxford Instruments are there. These are the major companies. They make fabrication plant machines, lithography machines, Scrollasky furnace, then etching etching tub, then penetration machines. These machines are being designed by these big companies, and some other companies are there like Kodak is there, and some couple of other companies provide raw materials like silicon, then silicon ink, that is silicon, liquid silicon, or the ingot directly they will provide, or some company there they build the wafer and send it to the fabrication plant, because wafer is not made inside the fabrication plant. Wafer is made in some other company. They wafers in their organization like TSMC outsource it from some other company. Then they build it. Okay, so this is the how a lithography structure inside the machine works. If you see these machines, I let me show you. Okay, so one second. See, this is huge lithography machine looks like in a industry, in a company. So you will be seeing, I think, like 10 to 12 machines will be inside TSMC Taiwan. That in TSMC Taiwan, if you sometime you get a chance to go inside TSMC Taiwan, you will able to see this ASML machine is there actually. I have seen the 28 nanometer ASML machine in TSMC, United States of America's fab lab. I have never visited Taiwan. I have seen the US's ASML machine actually, which is a 28 nanometer one. That now has came the 2 nanometer also has came. Okay, so this how huge the machines looks like of the ASML. Okay, so these are the couple of machines are there which support different particular nodes actually. So this is how complicated. If you see, you will see is how complicated this whole machinery looks like. You will see multiple keynotes are there. This is the machineries thing. You will see multiple so wafer handling is there, then wafer stage is there. You can go to the website also. Optical column, then reticles, multiple things are there. This is the actually light source from where the light is originating, and it is actually being pointed to this wafer stage. This is the wafer stage actually kept here, and the light falls at this level by reflecting the mirror at a different angle placed, and it falls on this one, and it fabricates the chip actually. This is how complicated the whole machinery looks like. Okay, now coming to our topic. So this iron, that light is called the iron beam. That's iron beam actually. Okay. So iron beam, focus iron beam lithography has a high potential to play an important role in nanometer technology because of the lack of backscattered electrons. Okay, this is what you can say. What is the ion beam or ionization? You can ask, you can tell him or her. Ion beam lithography is a practice of scanning a focused beam of ions in a patterned fashion across the surface in order to create a nanostructure. Ion beam lithography has high potential to play an important role in nanometer technology because of lack of backscattered electron. You can tell them this definition. This is the definition of the ion beam lithography. Okay. Now comes to the what is the use of ion beam lithography. Ions have heavy mass than electrons. Okay. Less proximity effect due to backscattering, less scattering effect. They are much, they are very precise and pointed, offers high resolution patterning than UV. So earlier it was supposed to be UV and X-rays. UV is also used to be one of the light source earlier. Currently they are using ion beam only. Okay, so offers high resolution patterning than UV lithography because these heavier particles have more momentum. Earlier, electron beam was very old, and this is very old. So recently, UV has been UV still is used in the industry. Moreover, ion beam is used moreover in this part. Okay, because UV is also used. The older technology is done with UV because due to the cost effectiveness. Because ion beam is much more expensive, offers high resolution patterning than, because the 2 nanometer chip which is going to fabricated by the TSMC will be cost 750 they will be charging 750 million per wafer to fabricate one 2 nanometer chip. So it's roughly a 300 millimeter wafer. If it is, I think depends on the chip size, they can, I think, fabricate 100 or 100. I think if I take 100 chips, then the cost of the whole 300 millimeter wafer will cost $750 million. Okay, so that is how actually expensive that thing is. So offer high resolution patterning than UV. Okay, because it is heavy particle and have more momentum, because this X-ray, UV, and electron beam. This gives the ion beam a smaller wavelength than even an E-beam, and therefore almost no diffractions. The momentum also reduce scattering in the target and in the residual gas. The momentum also reduce scattering in the target. There is also reduced potential radiation effect to sensitive underlying structure compared to X-ray and E-beam lithography. These are the some advantages of the ion beam lithography over UV, X-ray, and electron beam. Okay, so the momentum also reduce scattering. The momentum what it has, it reduces scattering of that thing. Okay, because it has heavy actually, it's a heavy mass than electron, ion beam, and this is the advantages of the ion beam lithography over UV, X-ray, and electron. Okay, so up till here, is it clear? Can you guys confirm me? Hello, hello, hello. Okay. Now coming to the next part, which is called why use ion beam lithography. Why use ion beam lithography? Ion beam sources. These are the ion beam sources. Gas. Like what are the sources of the ion beam lithography? Okay, gas source, hydrogen, helium. Okay, these are the sources of the ion beam source. Okay, gas source like hydrogen and helium. Metal source. The most common use of metal is gallium, Ga. Okay, or AU, SI and AuSiB alloys have been also used for lithography because these sources can supply light mass ions, lighter mass ions. Okay, so these are the couple. If anyone asks you what are the sources of ion beam, you can say if it is a gas source, then hydrogen or helium they will be using. If it is a metal source, then they will be using uh, if it is a very common used metal, they use gallium, or sometimes they use AU also, SI or BE alloys also. Okay, AUSI mixture alloy they use because they are good for lithography because these sources can supply lighter mass ions. Okay. That is the reason these are the sources of the lithography, ion beam lithography. Okay. How ion beam sources are made. Several other implementations are there, like focused IBL, direct writing, masked IBL, beam passes through an ion transport patterned with absorber material position closest to the coated substrate. So apart from this several implementation, this is the major implementation is done by the industry actually. These are very rare because these things are majorly used. So you can tell this, you can eliminate this thing. Several implementation, you can tell this ion beam sources, gas source, hydrogen, helium, metal source. You can tell them. It is much more easier to say to the guys. Okay, it is much more easy to, you can just say them like ion beam source, gas source, hydrogen, helium, metal source, like gallium most used, or alloys like AuSi or AuSiB used because they have a lighter. So that much and stop it. Okay, so you can just say them. So this is how it looks. Co-illuminated ion beam coming from the top, and a mask. This is the mask, and this is the wafer actually falling on with the light is falling. Okay, this is the structure how it looks like. Like why use ion beam lithography? Resist polymethyl what? Okay, PMMA, polymethyl methacrylate. PMMA is the most common polybutylene one sulfone. Uh, because there is a very chemistry term. We generally use PMMA. We don't pronunciate these big things. It's a part of our chemistry, guys. They will take care. So just I'm not going to pronounce it. It's very bad pronunciation. So resists will be PMMA, which is polymethyl methacrylate, is most common. Actually, PMMA technique is very most common. Why use I'm saying PMMA, you can say, or the polybutane 1 sulfone and poly 222 trifluoroethylene a chloroscrylate. Never use this one, these big terms. Better say PMMA is the PMMA is the most common technique used in the industry. So just tell why use ion lithography. Resist is PMMA. Simple. Like feature is penetration of the particle beam is small compared to electron beam. Like penetration of particle beam is small compared to electron beam in this one ion beam lithography. Reduce blurring resulting from beam scattering. Blurring effect is very less in this one. Reduce proximity effect, increase localization precision, because the ion beam lithography is much more precise in compared to the other electron beam UV or X-rays. So the blurring is very less. The designs are much more precious and much more efficient in the ion beam lithography. That is the reason we use ion beam lithography across the industry. Okay, which is the current in the scenario use. Focus ion beam lithography. What is focus ion beam lithography? In focus ion beam lithography, you'll see simple columns, ion sources, single electrostatic lenses, electrostatic detector. Like how the machinery is what it says actually. What is in, if you see in what is inside this machinery, these are the components. A simple column, ion source, like if you see in helium, like kind of something metals. Okay, what is the ion source? First, single electrostatic lens, electrostatic detectors, two types: low acceleration voltage less than 50 kV, column without mass separation, and high acceleration stage above 100 kilovolt, column with mass separator. You have to tell this one what, like, I am very sure that no guy will ask you in the interview, like, what is it? The guy who will be taking your interview majorly will be either a maximum a senior engineer or a lead engineer. Okay, maximum they will ask. Not even manager will take, because you guys are fresher currently. Like, very rare a manager will take the interview. Majority case might be a product company manager can take, but majorly, if I tell you, a lead engineer, senior will ask you. If I frankly speak, very less guy know all this in details. They know what is fabrication from stepwise. You can tell, like, this is the anvil, this is the creation of the substrate, this is the metallization, this is the diffusion, this is the gate creation, this is the source and drain creation, metallization, finish. The fabrication is finished. Now, what is ion beam lithography? These all details very less guy will know. Managerial level guys will for sure they will know, because they work on those things. Okay, actually, okay. So very less guy will know all these details. So better don't try to get inside what is not asked actually in the be precise in the interview. Tell the guys what have been asked to you. Don't go in much depth. If you go in much depth, they will try to manipulate you. And if some manipulation happens, you will might get confused and you tell a wrong answer. Okay, if the wrong answer, they also don't know, you have tell the correct answer, or by mistakenly you have told the wrong answer, they will reject you. Because interview is a elimination test actually. They are sitting there to eliminate you and find the best one. Okay, so be precise, be conscious. Whatever is asked, tell that much only. Don't go left and right. You know this and that. If you try to show this kind of thing, for sure you will be in a trouble in the interview, because many guys will try to manipulate you, because interviewer does that many times. Okay, so be precise. Tell the hierarchy. It is for your own knowledge. When you enter the industry, then you implement it. But before that one, don't try to implement all these things in the interview. Be very precise. Like, what is fabrication? Just tell them step by step. If they particularly asks you what is ion beam lithography, then focusly tell. This is ion beam lithography. These are the types of source of ion beam lithography. This is how ion beam lithography is done. Stop. What are the components inside that machinery? I think no one will ask. Like, very rare. In 100, like only very 0.1% will ask. Okay, so very precise. So lithography, this is the machinery's components inside the ion beam lithography available. Okay, now if you come to the low voltage column without mass separator, if you see, this is the actually ion beam lithography machinery. That the big machinery has this kind of component, with a heater, a reservoir where the liquid gallium is present with Ga, that we shown. Then that's the actually responsible for creating the ion source. A tungsten needle is there. Okay, so from where the ion beam lithography will pass actually, then emitting tip from it will it get emitted. Okay, then extraction electrode. The multiple components are there. Some lenses will be there actually. Okay, and then at last the target, which is the wafer actually. Okay, so this is the ion beam lithography structure. Remember this structure by practicing out in your paper. If someone asks how ion beam lithography structure looks like, you can just draw it. Just write heater, liquid gallium or reservoir, tungsten tip, that much. Then put one or two lenses in between, accelerating lens of electrode. Just put these lenses here, like you can put the lenses here, and at last you can put the target. Simple. Done. This is the structure of the ion beam lithography, how it looks. Okay, now comes to the higher, this is the low voltage one, this is the low voltage acceleration, this should be the high voltage acceleration. Okay, there were two actually. So high acceleration voltage column, so this is the high, this is the ion source, condenser lens, mass separator, and objective lens, and the beam deflector which is falling on the target wafer. This is how the structure looks like. So this is the simple description. You don't need the description. If you're going to fabrication plant, then only need all these things. Otherwise, this is just for your knowledge how the machinery looks like. The same thing, it's also here only how it is being done. So this is the same thing actually. Okay, same thing it is given again here. Okay, same diagram. So better use this diagram, it is much more easier to understand this diagram, much more easier to understand. Okay, so these are much more bit complicated, so this is much more easier to understand how ion beam lithography machine looks like. Okay, now come to the this thing. So that thing has been enlarged and shown here. Here that iron sources is there 25 kV, which is less than the low voltage one is at 50 kV. Then from the iron source, iron is generated. Here the 90-degree angling, the thing is there which actually deflects the iron which at a 90-degree angle. Then some kind of, what I can say, then some kind of biasing will be there here. Okay, then this will be focused from a lens and will be sent to the chamber where it can be sent to the device for the in a wafer. Okay, so then it comes at this and it targets the wafer. Then it comes, it targets the wafer actually. Okay, this is the circuit which has to be implemented on the wafer, which is integrated circuit. Suppose example it's integrated circuit for to be fabricated on a wafer, and this is how the light is falling. You can use this diagram also, or this diagram also, any diagram either from two. You can use it for your understanding. Okay, so up till here, is it clear to you? Hello,
Yeah, sir.
hello, up till here, is it clear?
Yeah, sir.
Actually, sound is not audible. Very less sound coming. Nageshwar, Rupali, Nilani.
Yes, sir. Yes, sir.
Okay. Like the what ion source, electron bombarded ion source, electron beam is directed onto a gas. Like what are the ion sources, how the ion source is created? You know that with a metal, gallium, or the gas hydrogen, helium, that's fine. But how ion source is created from them? Electron bombarded ion, so electron beam is directed onto the gas, produce low energy beam as a noble gas ion which is Ar plus or He minus, sorry, He plus. Gas discharge ion source. Ion are created by plasma or by electric discharge used in high energy accelerator and ion implanters for semiconductor manufacture. Okay. Field ionization sources operates by desorption of ion from a sharp tip in a strong electric field. Liquid metal ion source operates a desorption of metal ions from liquid metal under strong electrical field. So the ion source, how it is been created? It is been created by, it is being created by electron bombardment. The ion, that electron beam is falling inside a gas, onto a gas. That gas is either hydrogen or helium, which is producing a low energy beam or of a noble gas, that is Ar plus or He plus. Helium I already told. Okay, so this is how the ion source is created. Now the gas discharge of ion source, how the gas is discharged. Ions are created by plasma or by electric discharge. Beam or the plasma beam will be falling on that one. Okay, the discharge used in high energy accelerator and ion implanter for semiconductor manufacture. This is how ion is created, either using by electrical source, electric discharge by plasma. Okay, field ionization source operate by desorption of ion from a sharp tip in a strong electric field. A field ionization source operates by desorption of ion from a sharp tip in a strong electric field. You have to remember this. What is field ionization source? Okay, liquid metal ion source. Okay, operate by desorption of metal ions from a liquid metal under a strong electric field. These are two types of ion sources has been which can be created across this industry things. Let me de-highlight it. Okay, this is how this is being created: field ionization source, liquid metal ionization source. These are the two part. What I can say here is, in the part of the metal ionization source, these are the two again subpart how the two things are created: field ionization source and liquid metal ionization source. These are the two way how they have been created. Okay, so this is how the iron things are created actually. Okay, so generally metals are used because it is like gas is also used, metal is also used. Both in case these are used actually. So this is how iron beam sources are created. So many topics are there like gas iron sources, iron metal source. What is lithography things comes across that FIV metal milling and gas assisted processing. This is how the things are being created. Okay, so we will be talking all these things stage by stage. Okay, stage by stage we will be taking care of these things. Okay, so up till here, this is the way actually we create the ion sources. Up till here, we create the ion source. Okay, the two ion sets inside the metal ion source process is field ionization sources. First two ion sources, gas ion sources, metal ion sources. In metal ion sources, field ionization source and liquid metal ionization source. These two are the step. How these are done? Electron bombardment or using the plasma, either electric or the plasma they will be using this one. Okay, this is how the ions is being created. Now we will be going to the metal ions. What are the significance of the metal ion? What are the significance of the gas ion? Then how they are being used actually. Okay, up till here, you is it able to is it easy for you to understand how these things are working, how this diagram is working? So this diagram, what is focused ion beam lithography, what are the machineries in this one, why use ion beam lithography? Okay, so is it up till here it is clear that how and why, what are the reasons of using ion beam lithography for your machineries? Hello.
Low beam ionization is okay, sir. Rest things I need to get it because I am unable to understand those things because that is the first time I'm hearing that.
Which one?
Low beam ionization is okay, sir, for me.
Okay,
Rest of the things,
so let's rest which are the things you are not getting, you can tell me.
high ionization.
Okay. Okay, see, many things will come across because see, it is a much more details of the ionization beam. We have till up till here, we have listened like lithography. Then someone has told you, no, there is a ion beam lithography is there. That's fine. So like this is a much more depth of the ion beam lithography. How that lithography, if you see this violet light, this ion beam, how it is being created. There is a science behind that one. There is some couple of big machineries at the back end going on, then this light is being created. Okay, so this is how actually these lights are being created. So these are the parts of this low ionization and high ionization beam actually. Okay, 1 second. So this is how actually we are able to create this kind of ionization beams actually for our things. Okay, so you have to but just see the videos again. I will be sharing this PPT with you apart from that one, what I have shared earlier. Up till the lithography thing, I will be sharing from the etching to lithography thing. I will be sharing it to you. Don't worry. So just go through it. Watch the video again if required. I will be explaining you this thing. Okay. See, these things are very new to you guys. Okay. So it for me when I started, it only took for me like 7 days to understand the whole CMOS fabrication process. 7 days or more than that one only. I don't remember. It took for me to understand. So it's big difficult to understand everything. I will be sending one video. It will be much more easier to understand for you. I have seen one video. I have a YouTube video. I will be sending that YouTube video, guys. Just to have a look of that one. You will get much more clearance of the the whole fabrication process. Okay. Hello.
Yes, sir. Okay.
Okay, up till today we will be studying up till this point only. We're taking call for next tomorrow again. So 15th to 18th I won't be available. So there will be no class. I already told earlier also. 15th to 18th no class. I will be adjusting all those things in a some time. Someday I can take 2 hours if you don't have any problem, or in a over the weekend I will adjust it somehow. Okay. So now can Nageshwar, can you show your screen so that I can help you out once?
Yes, sir. Yes, sir. Please stop recording, sir. That will be increasing in
No, that I'm stopping.
just fine.